All right, so LT3, we started this in class, but we're distinguishing between a correlation and a causation when describing a scatter plot. And so one of the things we talked about in class is really questioning some of the statistics that you hear or some of the graphics that you see. Because there's a difference between two things being correlated and two things having a causal relationship, or one causing the other. So a correlation, we've been talking about these for a while, and so this is something that you kind of already know, but a correlation is just how two variables are related. And you know that we've talked about the various different types of correlation: positive, negative, strong, weak. We talked about a correlation coefficient that represents the relationship. A causation has the root word, if you want to talk about root words, tie in some language arts here. Cause right there, I don't know if it's one of the ones you're studying or not, but it has cause in front of it because it implies a relationship where one variable causes the other one. So the one variable being affected is a direct relationship with the other. So an example of this could be the number of, or I guess how far my dog has walked is caused by how many times I walk him, right? So if you have your two variables, miles walked by dog, that is directly caused or directly tied to the number of miles I walk him. All right, this doesn't increase without this one because I'm the only one that walks him. And so if this has increased, it's because I walked him. Me taking him for a walk is the only way he's going to walk more miles. All right. Now you can say, like, well, what if he walks across the kitchen floor or something? Like, there's like 0.001 of a mile. That's not really what I'm talking about. Okay. So maybe not the best example, but that's what I could come up with. There are other better examples, like profit versus how many cookies you sell at a bake sale. If the only thing you're selling is cookies, then the profit is only going to go up because you sold more cookies, and that's it. But either way, it's where one variable causes the other. And so if you look at this little picture that we have here, it has a little Venn diagram there. And if one side of this is people who have gone to the moon and the other side is people who have eaten chicken, this guy over here says, wow, look, like everybody who's ever been to the moon has eaten chicken. And then this guy makes an incorrect assumption in saying that chicken makes you go to the moon. In other words, because everyone who has been to the moon has eaten chicken at some point in their life, this guy is thinking, oh, eating chicken must cause you to go to the moon. So he's assuming a causation when really all it is a correlation. All right. We'll look at a few more examples. Study time versus quiz grade. If you look at this scatter plot, you can see that they have a positive correlation, and I would say you could make an argument for weak or strong with this. So I would maybe say this could have a correlation of 0.4, 0.5, 0.6, somewhere in that range. Remember, we're estimating anyways. And that would be the correlation. If we saw this as a causation, what that would mean is that every 10, like if you study 10 minutes, you are guaranteed a certain grade because your studying for 10 minutes caused you to get this grade, 65, whatever, okay? Or if you studied 20 minutes, no matter who you are, no matter what sort of prior knowledge you had, or any other factor, no other factors are considered. If you study for 20 minutes, you are guaranteed to get that score, 74-ish. So if this were a causation relationship, that would mean that studying for 0 minutes or 20 minutes or 40 minutes would cause you to get a certain score. And there are plenty of other factors that make that not true. Okay, so this would be a positive correlation between weak and strong, but it would not be a causation relationship because studying did not cause you to get a specific grade. Our next example, we have fresh lemons imported to the U.S. from Mexico and the total U.S. highway fatality rate. So first of all, you can see as the number of fresh lemons imported goes up, the total U.S. highway fatality rate goes down. But if you think about these two variables, the number of lemons that we bring into the United States from Mexico really has nothing to do with the highway fatality rate in the United States. Okay? So these two things would be correlated. Even though it doesn't make a ton of sense, there is still a correlation there because you can see these fatality rates are going down every time the fresh lemons goes up. So there is a correlation here. However, this more lemons imported does not cause more deaths on the highway. Okay? So you kind of have to take it out of math for a second. You can look at the math to see that there is a correlation here. And we know this is a negative correlation, and it might even be a pretty strong correlation for whatever reason. But if you think about the two variables, the imported lemons does not cause more deaths or fewer deaths. So this is not a causation. So in general, kind of what we're trying to get you to think about with this learning target are really the variables and the relationship between the two. If the correlation and causation are not always the same thing. And so one of the things that we're really trying to get you to think about are the two variables and if one truly causes the other one or not. And you can make, for a lot of these, you can make an argument either way. Like if you think about a few of the examples we've done in class, some of the ones that are maybe closer to a perfect correlation, you could make an argument for causation. You could also make an argument for just a correlation and not a causation. So one of the things we're trying to get you to do is distinguish between the two, but also know that there's not always an exact answer. Like this is not for sure just a correlation or for sure just a causation. And so what you're trying to do is create an argument to back up your opinion. Is really what, and that's kind of what you'll be graded on to for the test portion of this. Before class, I want you to be creative. Draw a picture of two variables that might be correlated but would not cause each other. So you've got the one example that was back here of the chicken and the moon. And then you have got this one here where this person down here is assuming that whenever you hold up an umbrella, it's going to rain. So they go outside and they hold up an umbrella and think that as soon as I hold up this umbrella, it's going to start raining because holding up an umbrella causes it to rain. So come up with something, be creative, be funny. I'm looking forward to what you guys can come up with for this, and we'll have a class discussion about correlation causation tomorrow.